Hey everybody, Jeffrey Powers from Geekazine. Think Magazine, put in a geek over at geekazine.com. Twitter handle, of course, Geekazine. I'm creating this video because I get this question a lot. It's about resolution and bitrate, and mostly about bitrate because there's a lot of confusion as to video resolution and how many megabits or kilobits get put out. Like, for instance, when we talk about audio podcasting, we talk about a 64 kilobit audio podcast, 96 kilobit audio podcast, 128 kilobit audio podcast, and then you can go up from there. And there's a whole bunch of in-between numbers. The whole idea is it takes kilobits per second to run the audio. So 64 kilobits per second for audio. Now, when it comes to video, it gets a little bit more confusing. You still have that bit rate, which is the underlying factor, but then we have 320p, we have 720p, 480i, 1080i, 1080p, and now 4K resolution. Now, of course, YouTube is starting a 4K version, and in all reality, it's not really a 4K resolution, but it looks a lot better than 1080. That sounds confusing, and I understand that. So, I'm going to try and explain all of this. I'm recording on a Sony, which is running what's called AVCHD, which is technically in 1080p. But I'm going to be converting this into 4K to, one, have my first 4K video up on YouTube, and two, to actually show you the resolutions that you get. Now, in 4K resolution, an uncompressed, or well, slightly compressed 4K resolution is about 45 megabytes per second, which makes a few minute file really large. We're talking a few hundred megabytes, and let's say a 15-minute video, 45 megabytes of a 15-minute video is a 2 or 3 gigabytes in size. 1080p runs at about its native is about 24 megabytes, which is about half of that. So you might have a 500 to 1 gigabyte file, and as you go down, it goes down from there. Now, in YouTube resolutions, it's a lot different because what they're trying to do is they're trying to give you that 1080p experience without having the full resolution. So if I had a 12 megabyte, let's say I created in 1080p and I recorded 24 megabytes, I would upload it to YouTube and they would recompress it to a lower bit rate. So like a 720p video, for example, would be about 1.1 megabytes per second, whereas a regular 720 video would be about 12 megabytes per second. So as you can see, they've pretty much dumbed it down to a ratio of 12 to 1. But they have a series of programs that actually make it look pretty decent for the file size that they're pushing through. And of course, the reason why they push through those smaller file sizes is simply because of the fact it takes a lot of money to go through the bandwidth like that, and a 12 megabyte uncompressed file is gonna cost a lot more, especially if thousands of people are watching it, as opposed to a 1.3, 1.4 megabyte file. So hopefully that explains a little bit. Of course, if you want to read more, I got the Wikipedia page up here. Basically, bitrate, sometimes written as bit rate or a variable of R, is the number of bits that are conveyed or processed during a unit of time. Here's what I'm going to do. We're running in 4K. I'm going to actually be doing different blocks. As you would actually see, if I put a 360p video in 4K, this is what you would see. So we're just going to go through the gamut really quick. And hopefully this will give you a better idea of what a person on a 4K TV or a 1080p TV would actually see if you compressed your video to that point. So we're starting with 4K. As you can see, it's pretty much got its full compression. I'm not sure what YouTube compresses to 4K because every time I try and download an MP4, it just it doesn't download back at the 4K that I uploaded it at. So, and I'm guessing it's going to be about 2.5 megabytes per second as opposed to the 1.4. So I'm just estimating on that because they're still working on what they're going to do for 4K. So we're starting at 4K. Now we're going to switch to a 1080p, which was, I believe, about 1.4, 1.5. And of course, with bitrate, this is also a variable bitrate, which means as my hands move and my lips move, you'll see that the bitrate will be higher. It'll be like 2 megabytes, because as opposed to the 1.2, because it'll actually have a range of between 1.2 and 2.5. And the whole idea, if I stood still, if I did this, by doing that, it doesn't have to change anything on the screen. Therefore, it can kind of remember the last picture that was used. The best thing is to have as static of a background as possible and little movement. So my mouth moves, my hands move. That's pretty much my videos here. So let's switch. Now we're going to switch over to 1080p, and we're going to do that now. So this is a 1080p video. And as you can see, probably little to no difference between the 4K video, mostly because of the fact that, like I said, I'm coming from a camera that, even though it does AVC HD at 24 megabytes a second, it's technically, I had to ramp up to 4K as opposed to ramp down to 1080p. Now, we're going to go to 720p, which, just an explanation, we're not talking about bitrate, we're talking about screen resolution, and screen resolution is figured between, across and down, and that's your 720. How many pixels across and how many pixels down equals 720p. So now we're going to switch to 720p. Here's that same video in 720p. Now, as you notice, the audio is not changed one bit, and I'm not going to mess with the audio at all. You can change the rate of the audio. Right now, I think we're going to be doing and YouTube will definitely compress to 192 kilobits per second for the best audio sound, and that's what we're going to do. We're going to keep that at. I'm actually going to encode it in 190. And then go from there. But this is 720p. Now, here's where we go next. We're going to go actually to 480p. Now, normally in a 480p situation, you lose these sides right here, and everything gets scrunched down to what's called SD resolution, and then 480p or 480i will become like a letterbox from there. We're not going to do that. We're going to keep it as full screen as possible as we go to 480p, and we're going to do that now. All right, now we're in 480p. You're really starting to see the difference in the 1080p to the 480p. So now we're in 480p. As you can see, like I said, the audio is going to be the same. We're not going to mess with the audio, but we're going to show. I'm just showing you the difference between the two resolutions. Now we're going to go to 480i, which is called an interlaced. It's actually a smaller resolution, and the idea, well, we'll talk about it. First of all, this is 480i. All right, now we're in 480i. What happens here is that I'm now interlaced, which means you might see some lines as I move my hands. You might see some jagged lines come through there, depending on what type of program you use to actually convert your video. You might see this interlaced version, and it looks weird, but it's all about the refresh rate on the TV, on the monitor, and that's what makes that 480i resolution go from there. Now we're going to go down. There's three more resolutions I'm going to show you. The first one is called 360p. All right, now we're in 360p. This is when iPhones first came out, and second generation iPhones, they wanted you to create video in 360p because in smaller screens, it looks really well. Larger screens, not so much. If you're watching from a TV, which I highly recommend you do for this test, check it out. You'll actually see the difference between 1080p and 4K as opposed to this resolution. Once again, in these types of situations, everything, the full screen would then be put to an SD screen, so it'd be perfect for watching on an old CRT monitor, for example. And of course, it would be all letterbox, but I'm keeping it full screen just to give you this idea. So this was 360p. Now we're going to go to 240p, which is the next step down. Once again, this isn't about the bit rate. This is about the resolution between across and down. All right, now we're at 240p. As you can see, if you're watching on a TV that does at least 1080p, this video looks pretty much like junk. It's blurry, it's blocky, it's horrible. And once again, it would be perfect on a smartphone, an iPhone from 2007, Today, not so much. Even if you watch it on your computer's monitor, you see blockiness, you see blurriness. It doesn't look great. But it's, these are the first videos. In fact, the first YouTube video was I believe just in 240p, but I'm not 100% sure. I'd have to double check on that. And of course, the bit rate on here is pretty low. Before we talked about 1080p and 720p being about 1 megabyte. Now we're in the 768 kilobit, 500 to 768 kilobit range. So this video, if I was to do it in 240p, would come a lot faster to you as opposed to the higher ends. Now we're going to go one more, and the reason why I'm doing this is because YouTube has it. It is the 144p. The reason why Google I'll talk about that. Here's 144p. This is probably the smallest resolution. It's around 320 kilobits to 500 kilobits in size. Now, YouTube put 144p simply for Google Glass, and I don't have my Google Glass on, but I'll put it on right here. If I was to watch a video on my Google Glass, even if it was 1080p, it would be dumbed down to 144p. So YouTube decided to do 144p. So if a video, once I start watching videos on my glass, if I ever do that, I can watch it easily and it actually go through pretty quick. Because we're talking somewhere larger, I'd say about 240 to 320 kilobits per second. Perfect for this screen, but when you get onto a big TV, it looks like junk. It looks blurry. So that is 144p. Now let's jump back up to the original size. All right, we're now back at the original size. As you can see, that's a big difference between the different resolutions and the different bit rates. Now, hopefully you understand a little bit more about what resolution is, which is basically the pixels across the screen times the pixels down the screen, kind of like square footage. You've got 1080 square feet to do your stuff. We talked about the P versus the I, the interlaced, the interlace stuff, which of course is the fact that it's not doing a full 1080p. It's compressing some of it, and you'll see some weird lines when you do that. And then of course, as we went down, the lowest end resolution 144p, which is about 160 to 240 kilobits per second, with all the way up to 4K, which can run 100, it's up to about 45 megabits per second if you are watching it full, as uncompressed as possible. But most likely with YouTube, we're talking about 2 to 3 megabytes per second when it comes to a 4K video. Hopefully that explains everything. Hopefully you get a better understanding of why that is. So when you create your video for YouTube, for Vimeo, or anything like that, you can actually adjust those bit rates, because all those bit rates are very adjustable. I can create a 4K video. In fact, I did it right here. I created a 4K video using a 160 kilobit per second video, and you can see the difference. So it's no different than in graphics. If you had a picture that's like super small and you tried to blow it up, it looks blurry, it looks blocky, and you can't use it for anything like a poster or anything professional like that. You need to have high resolution with a lot of pixels, a lot of information, so you can have the best picture possible. And that's the key right there. Hopefully that explained everything. If you have any questions, you can check me out at Geekazine. Once again, Think Magazine, put in a geek, you got Geekazine. Geekazine@gmail.com. I also have howtorecordpodcasts.com. If you're interested in actually recording podcasts, you can go over to Google and check out the podcaster community, which I am the owner of. And we have a lot of fun. We talk a lot about podcasting, audio and video, and go from there. Check out all the videos over at Geekazine. Make sure you subscribe, and thank you very much for watching this how-to, the difference between bitrate and screen resolution, and what it really means when somebody watches it on a big TV. Thanks a lot for watching, and take care.